This lab demonstrates how zone-based firewall policies can control communication between different network segments. Each PC belongs to its own subnet and security zone. The goal is to allow communication between PC1 and PC2 while preventing communication between PC1 and PC3. At this stage, no firewall zones or policies have been applied, so all networks can communicate freely with one another. I will now create separate firewall zones for each network segment. These zones logically separate traffic and allow policies to be enforced between networks. Each router interface is now assigned to its corresponding firewall zone. Once interfaces are placed into zones, traffic between zones become policy controlled. Now that the interfaces belong to separate zones, communication between the networks stops completely. This occurs because zone-based firewalls follow a default deny model, meaning traffic between zones is blocked unless explicitly permitted. I will now create a firewall policy that specifically blocks communication between PC1 and PC3 while allowing communication between PC1 and PC2. This demonstrates how firewall policies can selectively control traffic between security zones. With the policies configured, I will now apply them so the router can enforce traffic rules between defined zones. After applying the firewall policies, communication between PC1 and PC2 is successfully permitted in both directions, while communication between PC1 and PC3 is blocked as intended. This confirms that the zone-based firewall policies are functioning correctly. This lab demonstrates how zone-based firewalls provide granular control over inter-network communication by enforcing policies between security zones. Unlike traditional ACLs, zone-based firewalls operate on a default deny principle, making explicit policy design essential for secure network communication.